Our lesson today is on mass stoichiometry. This is an extension of the mole ratio lesson that we learned last. We have learned how to use a mole ratio to move between substances in a chemical reaction. But as we have learned with our mole calculations, it is much easier for us to use masses of reactants and products in order to discuss the amounts of substances. And now we can use that when we deal with chemical reactions. So while we still need a mole ratio, instead of starting with mole values or calculating mole values, we will just extend that and use the mole calculations that we have learned and apply masses. There are 3 steps when we do stoichiometry in chemical reactions. The first is to convert our known quantity into moles. And in order to do this, we use one of the 2 formulas that we have learned in class. So the one that we could use related to atoms or molecules, or better yet, the formula where we are given actual masses and molar masses. This is the one most often that we use because, again, we really can't count particles very well. We then use a mole ratio, as we learned in our last lesson, to move between your known and unknown substances of the reaction. And once we've calculated the moles of our unknown substance, in step 3, we're going to convert that mole back into a mass or particles sometimes, not often, but every once in a while, we may ask you to calculate the number of atoms or molecules. So let's go through an example and apply this mole ratio technique to our chemical reactions. But again, start from a more realistic point of view where we are given and asked to solve for masses. So in our first example, it says calculate the mass of carbon monoxide needed. So right off the bat, I'm going to come to my carbon monoxide substance in the reaction, and I am going to write down that I need to solve for the mass of this substance. And then they're telling me that we're going to start with 50 grams of Fe2O3. So I come over to the other reactant and I write down its mass. I really encourage you to write down what you know and don't know here underneath each of your substances in your reaction. It helps you to organize your work. We now know that we can only set up a mole ratio between 2 substances. And while it's interesting to know what the products are, we don't need them in this particular question. So we are just simply going to be asked to solve for the mass of our carbon monoxide amount. And if we go back up to those 3 steps, the very first step is to convert our known amount, which is right here, into moles. So this is step 1. So we're going to figure out the moles of Fe2O3. And we've been given a mass value, so we need to use the mass formula, mass divided by molar mass. And write down your formula, write down what it is you're solving for. You have 4 different substances here. Make sure it is clear. We're going to sub in the mass of iron 3 oxide of 50 grams. And we know that the molar mass, we can calculate this, is equal to 159.70 grams per mole. So you would calculate that off to the side initially. I have done that for you already. So I know I don't have 1 mole, right? 1 mole would weigh 159.70 grams. I only have 50 grams. This works out to be 0.31309. So again, as we move through multi-step questions, don't round to significant figures. Hang on to everything in that calculator display, but write down, values that have 4 to 5 decimal places. Okay, if we go back to the note, step 2 says use a mole ratio to convert between known and unknown substances. So we're going to write a step 2 here. And over in my reaction, this is step 2, me moving in a mole ratio from my known substance, which is Fe2O3, to carbon monoxide. And I notice it's a 1-to-3 ratio. Well, I don't have 1 mole of Fe2O3, as the coefficient suggests. I have 0.313 moles. And that's okay. We can still set up a mole ratio. We're going to put our unknown in the numerator, We're going to compare that to the known amount that has been given to us. So again, they didn't give us the amount of moles, but they gave us the mass and we could calculate it. So 31309 moles, and write down that it is of Fe2O3. Again, you have many different substances here. Remember that the other side of the mole ratio are the coefficients. So I have carbon monoxide in my numerator. I write the coefficient for carbon monoxide in the numerator on the other side, and then I divide out by 1 mole of Fe2O3. So I know I'm going to need 3 times the amount of carbon monoxide than whatever amount of Fe2O3 I start with. You're going to cross multiply this number over to the moles of carbon monoxide, divide out by 1. You get an answer of 0.93926 moles is what I'm going to write. And again, don't clear out that number out of your calculator. The odds are very good. You're going to take that number in the next step and either multiply or divide it. So step 3 is now to convert that mole value into more useful values for us. And here we want to know the mass. So we want to know what is the mass of carbon monoxide, and we're going to take moles times the molar mass. So right here now is step 3. And again, you can kind of follow that along in all of your reactions and follow along your steps. Just keep track of the different substances you're dealing with. So my mole value is 0.93926 mole, and I'm going to multiply that by the molar mass of carbon monoxide, which is 28.01 grams per mole. So I'm going to have close to that because I have close to a mole. I have 0.939, so it'll be just under 28 grams, and we're going to round to 3 sig figs here. I get an answer of 26.3 grams. Okay, let's do one more example where we run you through this 3-step method. So as always, you have to have a balanced chemical equation. We've given that to you. And then it's really in your best interest to jot down what you know and what are you solving for underneath the reaction. So it says calculate the mass of iron produced. So we're coming over here. We're now going to be asked to solve for a product when 125 grams of carbon monoxide, so one of our reactants, we're going to react that. They want us to know how much iron are we going to get. So again, with stoichiometry, you can only do calculations for 2 substances. And we can ask you anything in these equations. So we can ask you about products, we can ask you about reactants. It's the same 3 steps every time. So step number 1 is to convert my known quantity into moles. So my known quantity is right here. So this will be step 1. And I'm going to figure out the moles of, carbon monoxide, put that in, by taking the mass of it divided by the molar mass. So 125 grams, and then the molar mass of carbon monoxide, carbon is 1201, and oxygen is 16. I get a molar mass of 28.01 grams per mole. Okay, so I know that I am going to have more than 1 mole here because 1 mole weighs 28 grams. I have 125 grams. When I do that calculation, I end up with 4.4627 mole. We now are going to move to my unknown. So this is when I have to set up a mole ratio, and I'm moving now in the chemical equation to my unknown value. So I want to know how many moles of iron am I going to produce if I'm starting off with 4.4627 moles of carbon monoxide. So we set this up that my unknown is in the numerator. I set it up so that my given or my known is in the denominator, 4.4627 moles of carbon monoxide. And then I equate that to the coefficients on the other side. So I'll make 2 moles of iron if I start off with 3 moles of carbon monoxide. And I'm almost there. I don't have 3 moles. I have 4.45, call it, or 4.46. But still, I have to do or set up the ratio to get the calculation correctly solved. So we're going to cross multiply those moles of CO by 2 moles of iron, divide out by 3 moles of carbon monoxide. And I'm going to get a mole value of iron of 2.9751 mole. Okay. So we're not done. Again, solving for moles is a good thing, but it's better for us, more useful to convert it into usually a mass value. So step 3, we're going to now come over here to my reaction, and I'm solving for my unknown amount, which is mass of iron. And I'm going to use my mole times molar mass formula, and I'm going to sub in my values. So 2.9751 mole of iron, and the molar mass of iron is 55.85 grams per mole. I have about 3 moles, so you can already estimate you're going to have, over 150 grams at least. When I do the math, I need 3 sig figs from that starting bit of data that they gave me. And so my rounded mass value is 166 grams. Here's a third example on your lesson sheet that we're going to get you to try on your own. So write down all the substances that you know. What are you solving for? Notice that we are asking you to calculate the molecules of CO2 in this particular question, which you can do. You have both mole formulas. Try to come up with that answer. Good luck.